Alright, so we looked yesterday very briefly at negative indices. We're going to come back to it now, see if we can get it. Negative fractional indices. We're looking at these specifically in the context of deriving, but before we start we need to look at some key index laws to make sure we understand what they are. So if I've got a to the power of m divided by n, what does that mean? A is my base, so it stays as A. Harry.
It's like square root n of the...
Yep, it's a root that's to the nth power. And what happens? Sorry, to the n power, not the m power. To the n power, and then what do we do with the m? It's the power of a, okay? Now, what is one of the numbers that we do not put a number for at the front of our root? If I write the x, what does that mean? Square root, what's the number? 2. So just be aware of that convention, that if we're dealing with something on 2, we don't need to write the number. If you'd like to write the number, feel free. Cool? What does a to the negative m, what does that mean? 1 over a to the power of m. So what do you think happens to a to the power of negative m on n? Well, let's get rid of the negative first. How do we get rid of the negative? Make it over. So that would equal 1 on a to the power of m on n, correct? Happy with that or not? Now what do you think happens? 1 over the nth root of a to the power of m. Now the reason we need to be familiar with this stuff is because it comes up quite a bit when we're dealing with our derivatives. And you'll see why. So if I gave us a function fx equals x to the power of, give me a fraction, 4 over 7, plus give me a negative number.
6.
Negative what?
6.
Negative 6, x to the negative 6. We should be able to derive that. We do each term individually. We use the same of laws, same rule that we use for our regular derivative. Just in case we forgot that, if I've got fx, x to the power of n, f dash x becomes n times x to the power of n minus 1. So just apply that rule to that function. Let's go. I'll give you 30 seconds, it shouldn't take you any longer. So Tom Hall, can you help me out? What's going to happen first?
You're going to derive the first...
Yep, the first term. So what happens when I derive that first term? What becomes the coefficient?
7. Oh.
So I take the power down, so what's the power?
7.
Is it?
4.
4 over 7, x to the power of. What's 4 over 7 minus 1? Negative 3 over 7. Who got that part of that right? Okay, what are we caught up with? Are we caught up with the multiplying down? Okay, so if we have 4 over 7, you can put that in your calculator if you like. But this could come up on a tech-free exam. 4 over 7 is going to be some decimal number. If I bring that down, I'm multiplying by 4 and dividing by 7. It's exactly the same value. Just like we'd do if we had 2 on the top. We'd bring the 2 down, we're bringing the 4 on 7 down. So if you didn't get caught there, where else would you have got caught? Taking 1 away from our fraction. Let's just show how that works. I've got 4 over 7 minus 1. What's the problem with that?
1 is counted as 7. 4.
Yeah, I can't do this yet, can I? What do I need to do before I can subtract these two? I need to get the same denominator, correct? How do I get the same denominator? Well, I divide this one. This one's got to be over 7, correct? What have I not done? I haven't multiplied the top by 7, so that becomes 7 over 7. What's 4 minus 7?
Negative 3.
And we keep our denominator the same. Are we happy with that? So that's the case for that one. What about the second one? What happens to it? What's the new coefficient? The old power, which is -6, correct? X to the power of? -7, because we have -6 minus 1, which is -7. Who got that one? Very good. Am I done yet? Could I leave it like that? Yes, but conventionally in maths, what do we like to see? Yeah, we don't like to see fractional powers, we don't like to see negative powers, so we like to simplify a little bit. So let's get rid of the negatives first. So does the 4 go down the bottom, or does it stay on the top? It stays on the top because it's not associated with the power. What about my 7? Do I just leave it? Yep. What happens to my x? Goes in the bottom. Do I flip the powers or anything?
Yeah.
Should just be 3 over 7 still. No flipping of the powers required. I flip them down the bottom, like I take them to the denominator, I don't change the fraction itself. Does that make sense? It's still 3 over 7. I'm going to make this minus. What happens to my 6? Is it go down the bottom or does it stay on the top? Stays on the top. 6 divided by x to the power of 7. Am I done? Not yet. What do I have to do? Get rid of this fractional power. So I've got 4 over 7 to the 7th root of x to the power of 3 minus 6 over x to the power of 7. It looks disgusting, but I would normally separate those 7 a little bit. Cool?